will discuss about variation of atomic radii in periods. Okay, so atomic radii of an element decreases across a period from left to right. So in period when we are going from left to right, atomic radii is decreasing. Okay, why? Because as we go right, electrons enter into the same main shell or even inner shell in case of d black and f black elements. Okay, therefore there should be no change in a distance between the nucleus and outermost shell, but the nuclear charge is increases because of the increasing in the atomic number of a element in period. Hence the nuclear attraction on outer shell electron is increases. As a result, the size of the atom decreases. So in period when we are going from left to right, atomic number is increasing. So atomic number means nothing but number of protons. Okay, so number of positive charges. Okay, so in period from left to right, atomic number is increasing. If the atomic number is increasing, means number of protons are increasing. So here the atomic number is increasing, no? So here the atomic number is increasing. At the same time, nuclear attraction also increasing. Nuclear power also increasing on the outer shell electrons. Okay, so nuclear power also increasing on the outermost shell electrons. As a result, the size of the atom is decreases. Okay, so here atomic radii of elements is decreasing across the period from left to right. Atomic radii of element decreases across the period from left to right. Why? Because as we go to right, means in the period when we are going from left to right, electrons entering into the same main shell. Okay, entering into the same main shell. For example, once you take sodium is there. Sodium atomic number 11. Electronic configuration 1s2, 2s2, 2p6, 3s1. This is entering into 3 orbital only. Magnesium atomic number 12. So its electronic configuration 1s2, 2s2, 2p6, 3s2. It is entering into 3 shell only. Aluminium atomic number 13. Configuration 1s2, 2s2, 2p6, 3s2, 3p1. That is entering into 3 shell only. Silicon atomic number 14. Electron configuration 1s2, 2s2, 2p6, 3s2, 3p2. Entering into 3 shell only. Okay. Next to phosphorus atomic number 15. Electronic configuration 1s2, 2s2, 2p6, 3s2, 3p, 3s2, 3p3. Okay. Sulfur atomic number 16. Electronic configuration 1s2, 2s2, 2p6, 3s2, 3p4. Electron entering into same third shell only. Chlorine atomic number 17. Electron configuration 1s2, 2s2, 2p6, 3s2, 3p5. Electron entering into third shell only. Argon atomic number 18. Electron configuration 1s2, 2s2, 2p6, 3s2, 3p6. Means here in this sodium, magnesium, aluminum, silicon, phosphorus, sulfur, chlorine, argon. In this the electron entering into the same main shell. Okay. So left to right, electron entering into same main shell, but here proton number is increasing, means atomic number is increasing. Yes or no? Sodium 11, magnesium 12, aluminum 13, silicon 14, phosphorus 15, sulfur 16, chlorine 17, argon 18. Like this the atomic number is increasing. Atomic number is increasing means what happened? Proton number is increasing. Means these protons will be present in the center of the nucleus or not. From left to right, proton number is increasing, no? So this proton number is increasing means nucleus power is increasing. This nucleus pulling the last electrons towards itself with force. Okay, this nucleus power is increasing, no? From left to right, atomic number increasing. At the same time, this atomic number is nothing but number of protons. Protons will be present in the center of the nucleus. Okay, so this nucleus power is increasing, and that pulling the last electron towards the nucleus side. So due to this, the size of the atom is decreasing. Okay, that's why the size of the atom is decreasing. Okay, na? So in a period from left to right, what happened? Atomic radii is decreasing. Hello students, in last topic we discussed about atomic radius and how that will be changing in group and how it is changing in periods. Atomic radii means what? Atomic radii is nothing but the distance between the center of the nucleus to outer shell of a atom. okay na, the distance between the center of the nucleus to outer shell of a electron. Okay, the distance between the outermost shell of a electron and the center of the nucleus, this distance is called as atomic radius. This is measured in picometers. So this atomic radii, in groups it is increasing. Why? Because in groups, when we are going from top to bottom, atomic number is increasing. So atomic number is increasing, no, so then to accommodate the electrons, it's require more number of shells. Then for example, I will discuss examples also, examples also. Hydrogen, atomic number 1, so it will, the electron occupy first shell. Lithium, atomic number 3, it require 2 shells. Then distance between the center of the nucleus to second shell increasing. Okay, in hydrogen it require only 1 shell. The distance between the center of the nucleus to first shell, compare. Okay, lithium, atomic number 3, it require 2 shells, and then the distance between the center of the nucleus to second shell increasing. Sodium, it requires 3 shells. Okay, then distance between the center of the nucleus to third shell increasing or not increasing. So that's why in group top to bottom, the atomic radii is increasing. Next, in periods. So how is the atomic radius changing in periods? In periods, left to bottom, atomic radius is decreasing. Why? Because in the period, when we are going from left to right, its atomic number is increasing. Yes or no? Atomic number is increasing, but the electrons are entering into the same shell. Okay, already we took some examples, no, like sodium, magnesium, aluminum, silicon, phosphorus, sulfur, chlorine, argon. In that, the electrons are entering into the same main shell. Okay, so then what happened? The electrons entering into the same main shell, no? So the electrons entering into the same main shell, no? The nucleus power is increasing on the last electron. Okay, so the nucleus power is increasing on the last electron. So this nucleus is pulling the last electron towards itself. Okay, then the distance between the last shell and the nucleus is decreasing. That's why the atomic radii is decreasing in period left to right. Okay, why? Because when we are going from left to right, atomic number is increasing, means proton number is increasing, means nucleus power is increasing. So nucleus power is increasing, and that nucleus power is attracting the last electrons towards itself. So left to right, nucleus power is increasing, no, so that is pulling the last electron towards itself with more force. That's why the atomic radii is decreasing. Okay, that we discuss. Next, now we will discuss some examples. So here, do the atom of an element and ion have same size? Okay, atom of the element and ion have same size. What is the meaning of ion? Do you know about ion? Ion is nothing but sometimes to get octet. To get octet, sometimes atom of the elements losing the electrons or gaining the electrons. So do you know what is the meaning of octet rule? Octet rule means, so electrons are arranged in the shells. Electrons are arranged in the shells. Electrons are arranged in the shells. So if first shell we can accommodate 2 electrons, second shell we can accommodate 8 electrons, third shell we can accommodate 18 electrons, fourth shell we can accommodate 32 electrons. Like that, this we learn in 9th class, no? So like that, here, if in the last shell 8 electrons are there, then the atom of the element is stable. Okay, if in the last shell, if 8 electrons are not there, then what happen? It is not stable. Okay, so that is called as octet rule. Okay, this is called as octet rule. If in the last shell 8 electrons are there, then the atom of the element is getting stability, that is stable. If in the last shell, if 8 electrons are not there, then that is not stable. Okay, so if 8 electrons are not there, then what happen? It is taking the electrons from another one. If more than 8 electrons are there, then what happen? It is giving electrons to another one. Okay, so about this octet rule and giving and taking, we will learn in next chapter, chemical bonding. Okay, so ion means nothing but to get octet. Okay, to get 8 electrons. Sometimes atoms atom of the elements losing the electrons, or sometimes it is gaining the electrons. Okay, so if it is losing the electrons, then we can call that as a ion, cation. Okay, sometimes to get octet it will taking the electron, then we can call that as a anion. Ion is nothing but sometimes atom of the elements to get octet losing the electrons or gaining the electrons. If it is losing the electrons, plus symbol will come. Okay, that is called as cation. Okay, sometimes it is taking the electrons, then negative symbol will come, then it is called as anion. About this cation anion we will discuss in next chapter in chemical bonding. So do the atom of an element and its ion have same size or not? Now we will discuss. Okay, atom of an element and its ion have same size or not? Now we will discuss. Okay, let us consider the following situation. Okay, so what we are discussing, do the atom of the element and its ion have same size or not? We will discuss. So assume that sodium atom has lost an electron and formed a cation of sodium Na plus. Okay, so which one between sodium and Na plus would have more size? Why? Okay, do you know sodium? Sodium is one of the element. Okay, this sodium lose one electron. Sodium atomic number how much? 11. Electronic configuration 1s2, 2s2, 2p6, 3s1. So it is stable, it is obey the octet rule? No. Why? Because in the last shell only one electron is there, 8 electrons are not there, so it is not stable. Okay, so then how it will become stable? This sodium, if it lose the one electron from 3s shell, then what happened? It is losing the one electron 3s shell, then what will come in last shell? 8 electrons will be there. Okay, from sodium in the first shell, sodium atomic number 11, its electronic configuration 1s2, 2s2, 2p6, 3s1. So last shell 1 electron is there, in 3s1 1 electron is there, so it is not stable. Okay, so to become stable it is losing that one electron. Remaining how many electrons are there? In first shell 1s2, 2 electrons are there. In second shell 2s2, 2p6. Total 8 electrons are there. Now it is losing, so now it have 8 electrons are there not? Yes, 8 electrons are there. So but it is losing 1 electron from 3s shell. Okay, so it is losing 1 electron now, and then it will form cation. Okay, it is losing 1 electron from 3s shell now, then we can call this as a ion. What is that ion? Cation. If it lose the electron, then we can call that as a ion. It is losing, no, that's why it is called as cation. For cation, plus symbol will come. Na plus, Na upside plus symbol will come. So Na plus means nothing but sodium cation, means it lose one electron. Okay na? So like that it will come. So here the sodium lose one electron and form cation of sodium Na plus. Okay, sodium losing one electron and it form cation. That cation is Na plus. So which one between Na and Na plus would have more size? Why? Okay, between Na and Na plus, which have more size? Why? Means Na plus have more size or Na have more size? Okay, which one having more size and why it is having like that? Now we will discuss. Okay, so here atomic number of sodium is 11. Yes or no? Yes. Therefore sodium atom contain 11 protons and 11 electrons in the outer electrons as S1. Okay, so sodium atomic number 11, therefore it has 11 electrons and 11 protons. Okay, in outer shell only one electron is there, means in 3s1. Okay, outermost shell is third shell. In 3s1 only one electron is there. Okay, next, on the other hand, Na plus has 11 protons but only 10 electrons. In sodium atoms 11 protons, 11 electrons are there, but in Na plus 11 protons are there and 10 electrons are there. Why 10 electrons? From third shell, from 3s, 1 electron is losing, no? That's why 10 electrons are there. Okay, understood? So from third shell it is losing one electron now from 3s, that's why it have only 10 electrons. Means Na plus has 11 protons and 10 electrons. Okay, so now the 3s shell of the Na plus level has no electrons in it, hence outer shell configuration is 2s2 2p6. So in Na plus in last shell, means in 3s level, electrons are not there. So what is its configuration? 1s2 2s2 2p6. Okay, yes or no? Na plus configuration, what is that? 1s2 2s2 2p6. So why 1s2 2s2 2p6? Why? Because one electron lose from 3s shell. So Na plus configuration 1s2 2s2 2p6. Okay, why? Because it is lose one electron from 3s shell. So here proton number is more than the electrons. Yes or no? In Na plus proton number is more than the electrons, means in Na plus 11 protons are there, 10 electrons are there. Okay, so the nucleus Na plus ion attracts the outermost shell electrons with strong nuclear force. As a result, the Na plus ion is shrink in size. So in Na plus 11 protons, 10 electrons are there. So here the proton number is more than the electron number. So that's why this proton number is more than the electron, no? So nucleus power is increasing. Why? Because proton number is more. So due to this nucleus power, it is attracting the electrons in last shell towards itself with more size. Okay, that's why the size of the Na plus ion is less than the sodium atom. Okay, in general, positive ion means cation of an element has less size than the neutral atom. So in Na and Na plus size is less. Why? Because in Na plus 11 protons, 10 electrons are there, means proton number is more than the electron. Proton number more means nucleus power will be more. So nucleus power is more and that is pulling the last electron towards itself. Okay, then its size will be shrink. Okay, so due to this reason Na plus have less size when we compare with Na. But in Na 11 protons, 11 electrons are there, same number is there. Okay, but in Na plus proton number is more than the electron number. So proton number more, no, nucleus power is more, that attracting the last electron towards itself with more force. That's why its size is shrinking. So Na plus having less size when we compare with the Na. Okay, so like that, between Cl and Cl minus, which have more size? Why? Okay, which one between Cl and Cl minus would have more size? Why? Cl means chlorine. Okay, Cl minus means chloride ion, anion. So here electronic configuration of chlorine is, what is the atomic number of chlorine? Chlorine atomic number is 17. Electronic configuration 1s2 2s2 2p6 3s2 3p5. Okay, so between the Cl and Cl minus, which have more size? Why? Cl minus means chlorine, atomic number 17, electronic configuration 1s2 2s2 2p6 3s2 3p5. So last shell, third shell. Okay, 3s2 3p5 means 5 plus 2, 7 electrons are there. It is stable? Not stable. So means it will obey the octet rule? Not obey the octet rule. Why? Because in third shell only 7 electrons are there, that is 3s2 3p5. So to get octet, how many are less? 1 is less. So this chlorine is taking one electron from another one. Okay, so when it is taking the electron from another one, then it will, in last shell, how many electrons will come? 8 electrons will come. Then it is stable or not? It will become stable. So it is taking electron from another one, then it will get 8 electrons and it's obey octet rule and it will become stable. Okay, so here chlorine is taking one electron from another, no, so that is called as anion. Okay, this chlorine is taking electron from another one, no, so then negative charge will come, means Cl minus negative symbol will come. Why? Because it is taking the electron from another one. Then we can call that as a ion. Okay, then we can call this as a ion, means anion. When it is taking the electron from another one, then we can call that as a anion. Okay, anion. For this negative symbol will come. Cl minus means chlorine anion. Okay, chloride ion also we can call. So between chlorine and Cl minus, which have more size? Y. Okay, so here electronic configuration of chlorine atom is 1s2, 2s2, 2p6, 3s2, 3p5. Okay. Electronic configuration of chloride means Cl minus. Cl minus ion electronic configuration what? 1s2, 2s2, 2p6, 3s2, 3p6. Why 3p6? Why? Because Cl minus means it is taking one electron from another one. No, that's why 3p6. Okay. So here both chlorine and chloride ion have 17 protons. Okay. 17 proton in each, but there are 17 electrons in chlorine atom, whereas 18 electrons in chloride ion. Therefore, nucleus attraction is less in Cl minus ion when compared with the chlorine atom. Therefore, the size of the chlorine atom is less than the size of the chloride ion. Okay, so general negative ion anion has bigger size than neutral atom. Okay, so in Cl, chlorine 17 electrons, 17 protons are there. In Cl minus means chloride anion, 17 protons, 18 electrons are there. So in the Cl minus, electron number will more when we compare with the proton number, means electrons are 18, protons are 17. Okay, but in Cl minus 17, but in Cl chlorine 17 electrons, 17 protons are there. Okay, in chlorine 17 electrons, 17 protons are there, but in Cl minus 17 protons, 18 electrons are there. So therefore nuclear attraction is less in Cl minus ion when we compare with the chlorine atom. Means in Cl minus ion 17 protons, 18 electrons are there. Nucleus power is less. Okay, why? Because electron number will be more when we compare with the proton number. So nucleus power will be less. Okay, but in the chlorine 17 protons, 17 electrons will be there. Nucleus power will be more. Okay. Okay, in Cl minus 17 protons, 18 electrons are there. So that's why nucleus power is less when we compare with the chlorine atom. But in chlorine atom 17 electrons, 17 protons are there. Here nucleus power will be more. Okay, in Cl minus 17 protons, 18 electrons are there. Nucleus power is less. That's why Cl minus has more size when we compare with the chlorine atom. Therefore the size of the chlorine atom is less in size when we compare with the Cl minus ions. In general, negative anion of an element has bigger size than the neutral atom. Means negative ion means anion that have bigger size when we compare with the neutral atom.
Hello students, in last topic